price discrimination can also be done by a monopsonist, not just by a monopolist. We know that monopsonist is only one buyer in the market, and when there is one buyer, it has a certain situation. And let us consider an example where there is one monopsonist, because he is mono, that is one, and it demands for two types of labor to produce a certain level of output, that is Q. So it can be modeled in this equation, and it is a simpler production function because capital is kept constant here. We know that capital has a role to play, however we have kept it silent here to keep the things simple. The wage rate to attract a given labor supply is W1 and W2. Wage rate for the first kind of labor, wage rate for second kind of labor. This is alpha 1, which is the intercept, this is beta 1, which is the slope, and this is L1, which is the first type of labor. Similar holds for the second equation of the wage. The monopsonist is assured to be competitive in its output market, so P is fixed. Since the output market is a perfectly competitive market, or at least competitive, so the price cannot be changed frequently, and it will be fixed, it will be given. This is what is told here. So we are taking that certain price level with the output that it can sell and get this much of the revenue. And this is the cost, and cost has two components. This is the cost for first kind of labor, and this is the cost for second kind of labor. This is Q, so we are going to put Q here. Its value was L1 plus L2, and W1, the wage equation was given. L1 remains as it is. Here again W2, its value was given, and L2 remains the same. Now further is nothing new, it is the same algebra that you have done many times before. We are rearranging and simplifying here. So after all of these steps, this is the final result for profit function. One thing which is noticeable is that labor 1 and labor 1 square, labor 2 and labor 2 square. So we have arranged the labor 1 terms before and then the labor 2 terms, and we are increasing their degree. So now we can try to optimize, and for that you know that we have to take the derivative with respect to the first choice variable and then with respect to the second choice variable. We can take this derivative easily, so you can pause the video and take the derivatives and see if the answers are correct. However, both of these are the first order conditions that we can use to find out the critical values. So we have rearranged these first order conditions. Just to remind you, we have extracted L1 from here and L2 from there, and you will see that we have L1 and L2 in their critical value form. Now if I use these critical values and put them into the profit function, it will give me the maximized profit function, and it will be written something like this on the left hand side of the equation. So you can see in the profit function I have replaced L1 with L1 asterisk here and there, and L2 is replaced with L2 asterisk and then again L2 asterisk. Now these steps can be done by you. These are simple algebra steps, and the rearrangement is done, clustering is done, and finally we get this value, which is the maximized value of the profit. So we can also find another thing here. Even though we have found the critical values and we have also found the optimized value, but still we can find another important value, and that is the equilibrium level of wage, because wage is to be paid. It's an important question that can be asked by the monopsonist, and it is also a serious concern for the labor. So we can find the equilibrium value of the wage for the first labor, and it will be labor 1 asterisk substituted here, and when we put its value it will become this. We can simplify this and it will become this equation, that is the wage equation at equilibrium for the first labor. We can do it for the second labor as well, and for that we will substitute the value of L2 asterisk in the second wage equation that we are given, and simplifying will give us this answer. However, here we have done it by using the virtue of symmetry, and we have simply replaced alpha 1 with alpha 2. Remaining values are there as they were. W1 asterisk is now considered to be W2 asterisk, but we can solve it. And for solving, simply we have to substitute the value, that is the critical value, and we have to substitute it in the wage equation which is given. These are those wage equations. So in this way we have learnt that how a monopsonist will do the price discrimination by paying different wages to different groups of labor, and it will try to maximize its profit. And we can also know that how much of the labor it will hire from which one of the markets, which will be informed via the critical values of labor, that is L1 asterisk and L2 asterisk. So this was yet another application of optimization. Thank you.